Okay, calculus. 11.5 is pretty long, but it's all about referencing the lines in 3Ds in different ways and the uses for those different ways we do this. For example, a vector, which helps you transfer from one point to the next, can be related in such a way that it has a starting point plus a certain number times time. And then we can create a reference, which is a parametric reference, to how the line is moving over time. So the parametric equations of a line in space, if you have a vector v, which has values a, b, c, respectively, components, and a starting point, p, with values x, y, and z, then you can represent the line parallel to the vector passing through the point by x equals x1 plus at, y equals y1 plus bt, and z equals z1 plus ct. As long as a, b, and c are not 0, you can also get symmetric equations, because all of these have to be the same relative to time if you solve all of these equations for time. So find the parametric and symmetric equations of the line L that passes through 1, negative 2, 4, and is parallel to the vector 2, 4, 4. Well, it's quite simply, you take the point, and those are the constants. So x equals 1, y equals negative 2, z equals 4. And then it's plus the vector times time. So plus 2t, plus 4t, z equals minus 4t. Now, if you're going to get the symmetric equations, all you have to do is solve these equations for time. So we subtract 1, divide by 2. Add 2, divide by 4. And then z minus 4 over the negative 4. So it's not too bad to do this. So let's see how these apply to other types of problems, this idea. Parametric equations and symmetric equations are unique because you could choose a different point along the line parallel to the vector and get slight differences. If you start at different points, if you choose time or a different variable relative to time, if you went by half seconds or 10-second intervals, it would look different. So find a set of parametric equations through the point negative 2, 1, 0, and 1, 3, 5. Find where the line intersects the xy, xz, and yz planes. Now, if it's intersecting the xy plane, that means z is 0, xz plane, y is 0, yz plane, x is 0. So first, let's find the vector. In order to do that, we have to look at the difference between these two. That would be 1 minus negative 2, 3 minus 1, 5 minus 0, which is 3, 2, 5. And technically, we could choose either point as the starting point. I'm just going to choose the one with the 0. So we have x, y, and z. X is negative 2 plus 3t. Y is 1 plus 2t. Z is just 0 plus 5t, so 5t. So for the xy plane, we set z equals to 0. If z equals 0, then 0 equals 5t, which means t equals 0, and I can take that 0 and plug it in to the other two. So x equals negative 2 plus 0, y is 1 plus 0. So that means it intersects at the point x is negative 2, y is 1, and of course z is 0 because it's the xy plane. We can do the same thing for the other two planes. The xz plane, we set y equal to 0. 0 equals 1 plus 2t. So negative 1 equals 2t, so negative 1 half equals t. And take that and plug it in. X equals negative 2 plus 3 times negative 1 half. C equals 5 times negative 1 half, which gives us this point of intersection. X, that would be negative 3 halves. Negative 2 makes negative 7 halves. Y is 0. Z is negative 5 halves. And lastly, the YZ plane, X is 0, So 0 equals negative 2 plus 3t. So that means t is 2/3. Plug that in for y and z. Y equals 1 plus 2 times 2/3. Z equals 5 times 2/3. So we get the intersection point. X is 0. Y is 7/3. Z is 10/3. So that's something you can do with this idea. Now, if you consider a plane containing a point having a non-zero normal vector n, as shown to the right, so that means it's orthogonal. The plane consists of all points for which the vector is orthogonal to n, because if this vector is in a plane and it's orthogonal to n, all other vectors in this plane are also orthogonal to n. So using the dot product, n dot the vector pq is 0, which means that the vector abc dot, we know what pq is based on the parametric equations, and we know how to do the dot product by multiplying the components, and you get a times x minus x1 plus b times y minus y1 plus c times z minus c1 equals 0. So for a standard equation of a plane in space, the plane containing the point and having a normal vector can be represented by this equation we just derived. Let's see if we can do a problem like that using this idea. Okay, so there's a standard form. You can count on a general form of the equation in the plane. It's ax plus by plus cz plus d equals 0. Because remember, x1, y1, and z1 were just constants. They could be expanded on and combined with the other constant. So general form is easy to work with. You take the coefficients, turn them into a vector. So find the equation in both standard form and general form of the plane containing the points 2, 1, 1, 1, 4, 1, and negative 2, 0, 4. So I'm going to take the vector created by 2, 1, 1 and 1, 4, 1 first. By subtracting, we get 1 minus 2, so negative 1. 4 minus 1 is 3. 1 minus 1 is 0. Now I'm going to do the same thing with 2, 1, 1 and negative 2, 0, 4 to get another vector in the other direction. So we have negative 2 minus 2 is negative 4. 0 minus 1 is negative 1. 4 minus 1 is 3. Now, in order to find the norm to those two, I need something orthogonal. To find something orthogonal, I need to take the cross product here. So we have I, j, k. It doesn't matter which order we do it. I'm going to put this one I did first. Negative 1, 3, 0, negative 4, negative 1, 3 in my matrix. And when I do that, I get I times 9 minus j times, looks like negative 3, plus k times negative 12 minus 1. So that's 9i plus 3j, plus 13k, excuse me. So negative 12, no, this is backwards. It should be 1 minus negative 12 plus 13k. Okay, so in order to do that, I just take these coefficients and I put them with the x, y, and z of my starting point, which is the 2, 1, 1. So we should have 9 times x minus 2 plus 3 times y minus 1 plus z, or 13, times z minus 1 equals 0. Just expand. So 9x minus 18 plus 3y minus 3 plus 13z minus 13 equals 0, and combine to get your general form equation. 9x plus 3y plus 13z looks like minus 34 equals 0. So we had standard form, general form. And that's all for this video.